So let's start with getting an expression for velocity of say some particle, say over here, thrown from this point. Say it's thrown from here and it's over here now. And say it is thrown with a velocity of say v naught, making an angle of theta. And here the velocity is v. Okay, so what we're trying to do over here is expression for velocity at p. So this being p. So we're trying to figure out the expression for the velocity of the particle at p. Okay. Yeah, I need that space. Now, how do we do it? First thing is we have to resolve. We need to consider that you have v naught. This will be cos theta. And we have v naught sin theta. That is, we are cutting down all of our discussion to, right, where is it? Horizontal and vertical. So we are talking about horizontal and vertical motion separately. So Vx and Vy is what we are looking at. So yeah, my variables are a bit different now. So we have V naught cos theta and V naught sin theta. So this is Vx, this is Vy. And here I'll consider those variables. So this is your Vx. And this is your Vy. So or Vp of y. Vp of y. Okay, so we're trying to get this expression for this too. So to begin with, so when the journey starts at t is equal to 0 seconds, you have your ux to be u v naught cos theta and uy to be v naught sin theta, where v naught is the initial velocity and theta is your angle of, what is that? Angle of projection. Angle of projection. Okay, so these are all the things that we know of. Next, we have, just a minute guys. We have, I need to change the color. We have the horizontal component. At point P, that is V of x is equal to, this is V naught cos theta. Why is that? Reason being, the object is not accelerated along horizontal direction that we know of, right? We know this. So we don't have the object to be accelerating along the x-axis. So this will not change. Now let's talk about vertical component at P. Vy is equal to, this is V naught sin theta minus gt. So how did I get that? This is nothing but V is equal to U plus AT formula. Okay. So we know that acceleration, not observation. Object is accelerated downward with minus g, us taking up and right as positive. So if I consider up and right as positive, so we have this to be negative. And of course, this is positive because it's upwards, minus gt. So these are your expressions. So these are simple and straightforward. Now the resulting speed, or actually resulting velocity at p. What will be the resulting velocity? It would be simple v x square plus vy square root, or we can call this as square of this. It would be so. Why? We know that this is vx, this is vy, and this would be your v. So this being the case, so we have vx square plus vy square and all of that. So square of this would be u square or v naught square, v naught x square. Again, you can see that all this is quite simple. Cos square theta plus, this is in the form of a square minus b square. So I don't need to put a bracket per se over here. Minus gt, the whole square. So this is y, by the way. So v naught x square cos square theta. So v square sine square theta plus d square t square minus 2gt v naught y sine theta. And this too will lead to, oh, that will not resolve anything. Then what else do we have? Oh, my bad. This is wrong. This is just v naught square itself. Wait, am I writing that? No, correct. So v naught square cos square theta, because it's v naught cos theta and v naught sine theta. V naught x. Okay, so from this to we can get one term and nothing else to solve. So we have the final expression. Okay, let me write v. So v naught square plus g square t square minus 2gt v naught. There's no y, by the way. Sorry about that. Sine theta to the power of half. Okay, guys, does it make sense? That's the final expression. Again, you don't have to remember all this. We're just discussing. Now the angle. So the angle made by this particle at this point, say if it's beta. So again, we can use simple trigonometry. So the angle of the vector, velocity vector, at P, so VP, that is basically so will be what? Tan of beta with respect to the horizontal, with the horizontal actually. I need to write that, if not it doesn't make sense. With the horizontal would be tan beta is equal to opposite by adjacent. Opposite is Vy, adjacent is Vx. So Vy is, we have it here, V naught sine theta minus gt, entire expression divided with V naught cos theta. That's it. So these are all general expressions. You don't have to memorize anything. This is to show how we can solve any given problem with a simple resolving of the vectors. So there is some set of variation that we'll have to see. Okay, so that's too fast actually. So when we throw an object, please, we'll observe part by part. So first we'll observe the resulting vector. Okay, so how the velocity varies, the yellow color line, see that? How it's changing the angle. At the top, what is happening? It's just bending to the right. And then it's going down, down, down. That's it, right? Now let's look at the horizontal vector. The orange one, have a look at that. Just observe that itself. What do you observe? That it's not changing, is it not? Can you see that? The length, it is same. If you guys want to measure that, you can measure it now with a scale. And now measure it again. Measure it again. Can you see that it's the same throughout? Now look at the green, that is your vertical velocity. Can you see that how it is decreasing? We have seen all of this with turtle. It deaccelerates, and because it's getting pulled down, it will accelerate again. And the velocity keeps increasing. Okay. So for all of this velocity, we have a general expression. And those are this. And one more thing that you can observe is the angle. How the yellow line makes a different set of angle with the orange line, because orange line is parallel to the horizontal line. So that is basically your beta. So you can see the beta, it's decreasing, decreasing, decreasing. It becomes 0 at the peak, and it is in anti-clock. No, wait, this is clockwise direction itself. Negative set of values, and so on and so forth. Okay, guys. So yeah, now you can pause, have a look at the expressions. Okay, that's it.